Welcome to the lecture on data types concerning the module on data. Part of the material presented in this lecture is taken from the following book, while transcription and interpretation errors are responsibility of the lecturer. In this lecture, the following concepts will be introduced: dataset, attribute, types of attributes including nominal, ordinal, interval, ratio, discrete, and continuous. Assume you work in a data mining company while a friend of yours is the chief executive officer of a telecommunication company. Your friend read an article where it is stated that data mining helps to make informed and actionable decisions in the retail sector. Your friend is curious to know from you whether using the data mining methodology it is possible to extract knowledge from data to help making effective decisions in the telecom sector. You tell your friend that you are available to analyze the telecom data to prove that data mining is effective to extract valuable and actionable knowledge from data. Your friend thanks you and promises to send you, as soon as we'll be back to the office, a file containing the data which are relevant to solve the churn problem, so the problem of discovering which are the unfaithful customers, so the so-called churners. After 2 days, you receive an email message from your friend with attached a TXT file named churn. You download and open the churn TXT file and inspect the first 4 columns and the first 10 lines, obtaining the following situation. In this file you recognize several names as the header of the file as area code, representing the code of the customer area, so the area where the customer lives. You also have day means, which represents the amount of minutes of call of the customer during the day. You also find eve means, which represents the same as day means, but it is related to the calls of the evening. And finally, you also find the variable churn, which is associated with the following question: does the customer churned? And you find that 2 are the possible values of the churn variable. So the values are n, which stands for no, and y, which stands for yes. So no churning and yes churning for the corresponding customer. During the inspection of the churn TXT file, you notice that the value of column day means for the first and third records takes the suspect value of question mark. So you ask your friend about the question mark value, who replies that it is the value which is used to mean that the value of the field is missing. In other terms, that value has not been recorded. Let us now introduce some data mining specific terminology which will be used next. In particular, we will use the term dataset in place of file, so in this case this will be a dataset. We will use the term attribute in place of column, so in this case we will have 4 columns, so 4 attributes, where an attribute is a property or characteristic of an object that may vary either from one object to another or from one time to another. Finally, we will use the term record, case, or observation interchangeably to indicate a row of the file. So in this case, this line, or row will be defined as record, case, or observation. In our case, we will have that the attribute eve means can vary from record to record. So this means that its value can vary, can change from rows to rows, so from record to record. We can also notice that the attribute area code associated with the first column takes integer values. According to what we have just noticed, each attribute is of a type, and the type should tell us what properties of the attribute are reflected in the values used to measure it. Knowing the type of an attribute is extremely important because it tells us which properties of the measured values are consistent with the underlying properties of the attribute, and therefore this allows us to avoid foolish actions as computing the average value of the attribute area code. Indeed, even if the attribute area code takes integer values, it is not a numerical quantity, but it is a symbolic quantity. So computing the average value of area code will be the same as computing the average value of a color, which is clearly meaningless. Inspecting the available dataset, we can make additional notes. For example, we can notice that the attribute Intel calls has many of the properties of numbers, and in particular it makes sense to compare and order different records in terms of international calls. As well, it makes sense to compute the difference between international calls values between different records, and also it makes sense to compute ratio of international calls values associated with different records of the available dataset. In such a setting, the following properties or operations of numbers are typically used to describe attributes. We have distinctness, order, addition, and multiplication. Distinctness allows us to check whether two values are equal or whether they are different. Order allows us to order the values of the particular attribute we are taking into account. Addition is related to the operation of summing or subtracting two different quantities, and finally multiplication is related to product and to ratio of two different quantities. On the basis of the presented properties, we can define four types of attributes. The first type is the attribute type nominal. The values of a nominal attribute are just different names. For example, nominal values provide only enough information to distinguish one object from another, so we can simply check whether two values are the same or whether they are different. Some examples of nominal attributes are area code, churn, state, for example eye color, and gender. The allowed operations on nominal attribute are to compute the mode, entropy value, and eventually to compute contingency tables. The second type of attribute is the ordinal attribute. In this case, the values of an ordinal attribute provide enough information to order different objects. Examples of ordinal attribute are bad, good, excellent, so values that allows to order in increasing order of relevance the judgment. Also grades is an example of ordinal attribute, and also street numbers. The allowed operations on ordinal attribute are to compute the median, percentiles, to compute rank correlation, and to perform run and sign tests. We have also to point out that the nominal and ordinal attribute will form the so-called categorical or qualitative attributes. The third type of attribute is the interval attribute. For interval attributes, the difference between values are meaningful. Instead, a unit of measurements exists and we can use the plus and minus operators. Examples of interval attribute are calendar dates and temperature measured in Celsius or Fahrenheit. The allowed operation on interval attribute are mean, standard deviation, Pearson's correlation, and T and F tests. The fourth and last type of attribute is the ratio attribute. For ratio attributes, both differences and ratios are meaningful. In this case, we can use the product and the division operator. Examples of ratio attributes are day means, if means, monetary quantities, length, electrical current values. The operations that are allowed on ratio attribute are geometric mean, harmonic mean, percentiles, and variation. We also have to say that the interval and ratio attribute form the numeric or quantitative attributes. An independent way of distinguishing between attributes is by the number of values they can take. In particular, we can have discrete attribute, where a discrete attribute has a finite or countably infinite set of values, and a discrete attribute can be categorical, as for example the transaction ID, the zip code, or the area code that we are presented in the previous data set. They can be numeric, as for example day means, evening means, or eventually a count attribute, or they can be of a special kind, binary attribute. Churn is an example of this kind. It is a special case where the attribute can take only two values, which are yes or no, but also gender, which can take value male and female, is an example of a binary discrete attribute. Attribute can also be continuous. A continuous attribute is one whose values are real numbers. Examples of continuous attribute include attributes as temperature, age, or weight. Typically, they are represented as floating point variables.